Okay, so let's go over everything related to the Oracle. Here in week 9 and the lecture folder, we have the off-chain folder and the on-chain folder. In the on-chain folder, there are just the source code for the validators. When we compile these validators, they are saved in the assets folder. And as you can see, we have the collateral validator, the minting policy. This minting is the minting policy for the stablecoin. The NFT policy, which is the same one Lars explained in a previous lesson, and the Oracle validator. And in the off-chain code, there's a lot of stuff because it's a fully fledged Next.js application. But what you care about is the off-chain code that is inside source and components here. In the mint NFT button, we have the off-chain code to actually mint the NFT. And in the Oracle React component, we have the off-chain code to deploy, update, and delete the Oracle. I put everything inside the front end because in our example, we update the Oracle manually, but in a real world scenario, you'll also have a backend folder containing the code to automatically update the Oracle. You don't want to do this by hand every block. Like we saw before, we need the NFT to deploy the Oracle, so we'll start with the NFT. If we go to the off-chain code of the NFT, we're going to go quickly over this because it's the same Lars showed in a previous lesson. I'm going to jump around quite a bit between the off-chain and the on-chain code. So if you feel lost, make sure to check where I'm at up here. So right now I'm in the NFT file in the on-chain code. Okay, so let's go to the top. This is the whole minting policy. I'm sure you remember that we get a transaction out reference and the token name as parameters. And then we check that the minting policy has to consume that UTXO and that the amount to be mint is 1. Here in the has UTXO, as you can see, we check that any of all the inputs we have a reference equal to the one we parameterize. So this minting policy will only be able to run once, because after we consume the UTXO that has that reference, there will be no ways for it to return true again. Now let's go to the off-chain code that deploys this. If we go to the NFT button, we have this mint NFT function that checks if we have an address, meaning that we have a connected wallet. Then we get a UTXO from the address. We don't care which UTXO. So if we go inside this get UTXO function, we see that we get all the UTXOs in this address, take the first one we got and return that one. So we don't really care which one. Now we store this UTXO in this variable and use that UTXO to get the final policy. If we go inside this function, we create the token name of the Oracle using a string and the from text function that takes a string and returns the hex of that string. Then we create the type of the parameters. In this case, we use 3 parameters because if we go to the code and the NFT and to the bottom, we see that here in the make wrap NFT policy, we provide 3 parameters: the transaction ID, the index of the UTXO, and the token name. So those 3 parameters are the one we have to provide here. The first one, bytes, in a previous version was called string, I think. So if you have that, you have to change it to the bytes function. The token name, this one is the type of the index, an integer, and this one is the bytes of the token name. And here we use the apply params script function that takes the compile validator without the params applied and applies it to the transaction hash, the output index, and the token name. After that, we get our final minting policy. We provide this minting policy to the minting policy to ID function to get the policy ID and use that policy ID and the token names in hex to create the asset class of the NFT. Then we set the app state. This is not part of the off-chain code. This is just to maintain the state of the front end to show stuff and activate and deactivate buttons. We also use these parameters as inputs to other functions, so we can share this state between all our components. But this is not strictly off-chain code. This is just the way we handle state in the Next.js app. So we got the final minting policy, and if we go back, not here, but I think, yeah, we return the NFT minting policy and the asset class. And this is exactly it. And now we have everything we need to actually create and submit the transaction. So we create a new transaction. This transaction has to mint assets. Which assets? This asset class, that is the NFT asset class. And we can mint only one because that's the only thing it's allowed to mint. And the redeemer of unit. We need to attach these minting policies so the node is able to actually run, because we need to run the script to get the NFT. And finally, we have to make sure we consume the UTXO we use to parameterize the NFT minting policy. If we don't consume this UTXO, it won't work. I mean, the transaction won't pass and that's it. So you have to try again, but actually consuming the UTXO. Then we balance the transaction and sign and submit. Once this mint NFT function runs, we will get an NFT in our wallet like we did in the UI. Once we got this NFT, we can use it to deploy the Oracle. So now let's go to the Oracle. This is the Oracle validator. Okay, so here are the imports. So the actual code starts here. We have an on-chain helper function to parse the Oracle's datum. We extracted this function outside our validator because we need to use it in other validators. And to avoid repetition, we just extract it. This parse Oracle datum is no special. The only thing, it takes a tx out, and the info takes the datum from this tx out, and if there's no datum, returns nothing. If there is an inline datum, it tries to parse it and return the datum. And if there's a hash of the datum, tries to find the datum and then parse it. If any of these cases fail, they all return nothing. So if we have the datum in some way or another, this parse oracle will return just datum. Now that we have this convenient function, we start with the actual validator. So we have the parameters. We're going to parameterize our oracle with the asset class of the NFT and the operator that is able to update and delete it. And the only two actions that are allowed is to either update the oracle or delete it. There's no need for the use redeemer we need to use before Vasil, because now we can just reference as an input and read the datum without consuming the UTXO. So now the only thing we need to do is either update it or delete it. And the actual datum, the value that we want to save, is an integer. This integer represents the rate of USD ADA, meaning the price of ADA in US dollars. In our specific case, the price is in cents, like we saw in the UI. So the validator takes the parameters, the rate as datum, and whichever redeemer we need, and then chooses the case based on the redeemer. If the redeemer is update, the transaction has to comply with all these checks. And if it's delete, it's just a single check that if it's the oracle's owner or not. As you can see here, we are ignoring the rate because we are not actually using the rate in the validation part. We are reading the rate as a reference input when we use it in other validators, but this validator doesn't really need to know the exact value of the rate. It just needs to know that it's a valid number. So in the case of updating the oracle, we first need to check if the token is missing from the input. Which token? The NFT. If we want to update the oracle, we have to make sure that we are consuming the previous oracle. We also have to check the same, but for the output, because if we are consuming the oracle with the NFT and we are updating it, that means that the oracle needs to still be there after the transaction. So the update transaction has to have the NFT coming in and coming out. We also need to check that only the owner of the oracle can update the oracle and that the output has a valid value as rate. To check that the input has the NFT, we just need to check the value of our own input and take the amount of that value of type of asset class NFT and check that the amount of NFT is equal to 1. To check if the NFT is there, we use this asset class value of. This takes a value and an asset class and returns the amount of tokens of that asset class in a value. We have the asset class, is the one we use to parameterize the oracle, and we need to get the value. To get the value, we use the txout value to extract the value from a txout, but first we have to get that value, and we use this own input function that uses this find own input function to look for the oracle input, and if there's nothing, there's an error, but if it finds it, we get the txin info and we use the txin info resolve to get the tx out from it. This tx out comes here, and that's how we check if the NFT comes in. Then the other check was that it has to go out. This is actually pretty much the same thing. We check the asset class value of the NFT. That has to be equal to 1. So 1 comes in, 1 goes out. The only difference is that now we get the value from the output instead of the input. And it's the same, except that now we use the get continuing outputs function to get the TX out. Okay, so far, we know that we are consuming the previous oracle and that we are generating a new oracle. Another thing that we need to check is that the person trying to update it is the actual owner of the oracle. So this is pretty simple, and we did plenty of time before. We have to check that the transaction is signed by the operator inside the oracle. And remember that oracle params contains the NFT and the operator. So that's where we get the PubKey hash to compare to the one that signs. And finally, we have to check that the output has a valid datum. This is also pretty simple because we already created this convenient parse oracle datum that returns the datum if we have it. nothing if we don't. So the only thing we need to do is to pass the own output, the output we are trying to create, to this function, and then use the isJust function to check if the result contains a value, meaning the datum, or if it returns nothing. And because the parse oracle datum tries to parse the datum to an integer, as you can see here, maybe integer, we can be sure that the output datum will contain an integer. And that's it. Those are all the checks needed to update. To delete it is way easier. We just need to know that you are the owner of the oracle, and that's it. Pretty simple. And that's the whole oracle. Now let's see how we can write an off-chain code that builds a transaction that is capable of satisfying all these requests. For that, we're going to go to the Oracle component. This React component contains all the off-chain code for all the transactions to deploy, update, and delete the Oracle. And the first thing we need to do is to create the type for the redeemer. As you recall, the only things we could do were either update or delete the Oracle. So this redeemer is pretty simple. Now, if we go to the deploy Oracle function, this function contains the off-chain code needed to create the transaction that is able to deploy the Oracle. Because we are sending a UTXO to a validator, we don't really need to satisfy any checks. So first we check that we have Lucid connected and we have an address, else we won't be able to submit anything. Then we get the pubkey hash from our address and use it to get the final script. Remember that the Oracle needed both the NFT and the pubkey hash of the owner as parameters. So we need to apply the validator to those two parameters. If we go to the get final script function, we see that it takes a pubkey hash and returns a pending validator. We just do a console log and check that we have Lucid running, that we have the NFT policy, and that we have the token name of the NFT. And then, same as before, we create the params type. In this case, there's 3 bytes, the NFT policy ID, the NFT token name, and the pubkey hash. Why? Because here in the Oracle on-chain code, if we go to the bottom, we see that here we created the make wrapped validator Lucid, because Lucid, as of now, cannot build the Oracle params itself, so it's more convenient to do it in Haskell. So we have to provide the NFT as the first parameter, the pubkey hash of the operator as second parameter, and that's it. Oh, this is the currency symbol. This is the token name. And this is the operator. So the comments were wrong. Okay. So we take the individual parameters and build the asset class to get the NFT and parse the pubkey hash. Use those two to create the Oracle params and provide the Oracle params as the final parameter of the validator. So if we go back to the off-chain code, as you can see here, the first one is the currency symbol, second one, the name, and third one, the pubkey hash. We apply the script to the parameters and get the final Oracle script. We return this Oracle script, and I think, yeah, here is the deploy Oracle. That's the script we get here and name Oracle. We check that the actual script is not null, is not undefined, and that we have the NFT asset class. And now we can start the process of building and submitting the transaction. Before building the transaction, we have to get the address that we want to send the transaction to and that address is the oracle's address. So we use this validator to address to get the oracle's address and set the state to keep all the buttons and everything updated. And now we create the actual transaction. As you can see, the transaction is super short and easy to follow. We create a new transaction that has to pay to a contract. Which contract? The Oracle contract. This transaction has to have a datum of type integer and value rate. This rate value, we take it from the UI. We just save whatever the user writes in the website and parse it to get the value we need, but that's a UI thing. It's just a number. And the value that we want to pay to the address is the NFT asset class, and the amount is 1. Then we sign and submit, and that's pretty much it. Now, to update the Oracle, we have to make sure that we already have the Oracle script. We cannot update it without having the script because we need the script to deploy it in the first time. We also need to have the NFT asset class and the actual UTXO that contains the NFT of the Oracle and the address. If you're curious how we got this Oracle NFT in the first place, I created a get Oracle NFT UTX function that runs every 5 seconds and gets all the UTXOs at the Oracle's address. And we filter the UTXOs using the asset class. And inside these UTXOs, we try to find the UTXO that has the same asset class as the NFT. If it's the Oracle, only one UTXO has to be left. If there's no NFT, it's because we didn't deploy the Oracle yet. This is just a convenience function. You can do this manually, but it's easier to just keep checking every 5 seconds. So once we have that, we set up the state with the Oracle with NFT UTXO. So now we have it at this state. And that's where we get it from. Now that we have all the parameters that we need, we get the PPP hash of the current wallet, and we build a transaction. This transaction is a bit more complicated than the previous one. We create a new transaction. This transaction has to collect a UTXO from the Oracle, and specifically the one that contains the NFT as a value. And because this UTXO is in the Oracle's address, we have to be able to satisfy all the Oracle's conditions. We have to provide the redeemer. The redeemer, in this case, we are updating the Oracle, so it's the update redeemer. Then we have to pay to a contract. Which contract? The Oracle contract with the same datum that we used before, but in this case, we will have ideally a different value of rate because some time passed or because someone manually updated it in the UI, and has to be paid as a value the NFT that we get when we collect from the previous UTXO. Finally, we have to attach the spending validator so the node is able to run it, and we have to make sure that we add the signer's key to the witnesses because that's one of the conditions that the Oracle checks. Finally, we balance the transaction and sign and submit. As you can see, this pay to contract part is the same as before. The only thing that changes is that we need to collect the UTXO from the previous Oracle to have the NFT that the Oracle checks from. And we have to make sure to provide our PPP hash and provide the script. Lastly, we have to check the delete Oracle function. In this case, it's even simpler. We only need to collect from the Oracle and add the signer's key because that's the only thing that the Oracle checks in the case of the delete redeemer. And same as before, we have to attach the spending validator. And in this case, we have the NFT. So we just choose to pay the NFT to our own wallet. Here is the sign and submit. This is pretty much how you will handle any Oracle. Of course, depending on the Oracle, the conditions will be different, but the idea of updating and deleting being the only thing needed to do is consistent in almost every case. Now that we have an Oracle that we can update and delete, let's see how we can use it to provide our own stablecoin.